Hi guys, this is Miss Scott again. So today we're gonna use quite a few of those triangle congruence postulates to answer this question. How can you use congruent triangles to prove sides or angles are congruent? So first we're gonna have to prove if triangles are congruent. Then we know that everything that matches in those triangles is congruent to each other. So this first theorem is very important. It tells us that corresponding parts of congruent triangles are congruent. So we don't write that out every time when we use it in a proof. We abbreviate it as C, P, C, T, C. All right. So if there are two or more congruent triangles, then the corresponding parts are congruent. And we can use that to prove just about any two parts in any two congruent triangles are the same measure or the same length, depending on what we're trying to find. So if you guys recall from a previous lesson, we had 5 different ways to show that two triangles were congruent. The first was side, 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 which remember that picture, you have two triangles that have all 3 sides are known. The second was side, angle, side. So you had, say, this triangle here, this angle, and then this angle matched up with another triangle. So remember, this is important. It had to be the angle in between, which we call the included angle. All right, and the third way was angle, side, angle. And for triangle using angle, side, angle, it would have to be 2 angles. And then the side in between we call the included side. Okay, the next way was angle, angle, side, so still knowing 2 angles. So say we have this triangle where we know this angle, we know this angle, and then we have this side, which is the non-included side, aka it's not between the 2 angles. And the last one, remember, only works for right triangles. That was hypotenuse leg. So in a right triangle, if you know that the hypotenuse is congruent to another hypotenuse and this leg is congruent to another leg in another triangle, that's the same. So remember, this is the hypotenuse. This one is a leg. All right, so we're going to use those today. Let's look at example 1, 2, and 3. So they tell us to use the figures at the right to give a reason for each statement below. Well, why can we tell that angle A is congruent to angle P? Well, they don't have any congruence marks there. They don't tell us that they're both the same number of degrees, but hopefully we can prove that these two triangles are congruent. So if you look here, I have angle C matches with angle R. I have angle B is congruent to angle Q. And I have that QP is congruent to BA. So we actually know for the first step, by angle, angle, side, the two triangles are congruent. Okay, that's actually what you can say here. We know triangle ABC, the one on the left, is congruent to triangle PQR, the one on the right, because they have an angle that matches, another angle that matches, and then the non-included side matches. So that's the first thing we can say. And then the second thing we can say is now if they're congruent triangles, all the parts match up. So A and P have to be congruent. That's that corresponding parts of congruent triangles are congruent. CPCTC. All right, same idea here. Now we know all the parts are congruent, so well, actually, this is kind of silly. BA is right here and QP is right here. Well, obviously those are congruent. They put tick marks on it. If they put tick marks on it for us, that's a given. All right, so those would be reasons that we could say each of those things. Okay, let's look at a proof using this stuff. So they tell us that M is the midpoint of WX and YZ. So with that only thing given, we're going to prove this. All right, so M is right in the middle of W, X, and YZ. Let's write that as our first statement. M is midpoint of segment WX and segment YZ. And that was just a given. All right, well, if that's true, let's take a look at what we could say next. If M is right in the middle of WX, that means WM has to be the same length as XM. So let's say that WM is congruent to XM, and that is simply the definition of a midpoint. It makes two congruent segments. All right, well, very similar thing we're going to say in our next step. M is also the middle of YZ, so that means YM is congruent to ZM. So segment YM is congruent to segment ZM. Again, using that definition of midpoint. All right. And we've actually got another hidden congruence here. This angle here and this angle here, so angle YMW, has to be congruent to angle ZMX because those are vertical angles, and we know that vertical angles are congruent. All right, we can now prove that these two triangles are congruent. If you notice, we have side, angle, side, so that's our next step. Triangle YMW is congruent to triangle ZMX by side, angle, side. And last but not least, now that we know these triangles are congruent, we can prove that WY, this segment on the left here, has to be congruent to segment XZ, this segment on the right side here, because corresponding parts of congruent triangles are congruent. CPCTC. If those triangles are congruent, all the corresponding pieces have to be the same. So YW matches with XZ, therefore they're congruent. All right, let's move along here. Doesn't hurt to look at another proof, so go ahead and flip to this proof here. Okay, given a couple things in this one, so we'll split that given information up. First thing they tell me is that segment AB is parallel to segment CD. So this line on the bottom where they have this arrow here is parallel to this line segment on the top. All right, so that's what we know because it's given. All right, we also know that angle C is congruent to angle B. And luckily they put some arcs on here for us, so that was another given. And you can probably see we've got something we can show because we know those lines are parallel. So these are actually alternate interior angles because they're inside the AB and CD and they're on alternate sides of this line AD. So I'm going to say angle B from B to A to D. That would be this angle up top is congruent to angle CA or CDA rather. That would be this angle on the bottom, because those are alternate interior angles, and we know that those are congruent when you have parallel lines. Okay, the next thing we can say is we've got this shared side in the middle. So AD is congruent to itself because of the reflexive property. All right, and lastly, I think we're actually missing a line here, but we can draw that in. The next thing we can say rather is now we have an angle, and that shared side. So if we have the same angle, and the non-included side, so we don't know the side between those two, but now we actually can say that the triangle on the top, triangle BAD, is congruent to the triangle on the bottom, triangle CDA, because of that angle side postulate. And then go ahead and just add a last line here. We have one more step because we are trying to prove that segment AC is congruent to segment DB. So AC is this segment on the left. That has to be congruent to segment BD on the right because of CPCTC. Okay. Alrighty, let's look at our next example. Number 6. This one has circle the triangles below that are congruent. So instead of writing out these names every single time, I'm just going to call this triangle 1, 2, 3, 4, and 5. So let's start over here with triangle 1. If we look at triangle 1, I'm trying to see if it's got anything in common with any of these other 3 angles or any of these other triangles here. Only thing that I can really see is, let's see, where do I have some matches? I've got a right angle here, and all the way over here. And then I also have this tick mark here, here, and here. So 1 and 5 have 2 things in common. And then I've got this angle on the top here, here, and here. Well, if you notice, those 3 marks I just made are the same on triangle 1 and triangle 5. That's angle side angle. So triangle 1 is congruent to triangle 5 by angle side angle. All right, so that's the first thing I can say. And now we can mark those 2 with corresponding parts of congruent triangles being congruent. So now I know that I can put this double tick mark on the bottom of triangle 5, and I can put this triple tick mark on the side of the first triangle. All right, well now I've got a ton of matching information. So if you look at triangle 1 and triangle 3, they have all 3 sides marked. So now I know triangle 1 is congruent to triangle 3 because all the sides are the same. All right, and again, I can mark with corresponding parts of congruent triangles are congruent. Okay, so let's see. 1 and 3 are the same, so that means 3 also has to have that angle and that right angle there. I think that's all that we can really say so far. And then now I'm going to compare 2 with 3. So these are right triangles, and I've got this hypotenuse matches this hypotenuse here. This leg matches this leg here. So triangle 2 is congruent to triangle 3 by hypotenuse leg. And now we know that triangle 1, 2, 3, and 5 are the ones that are congruent. 4 is actually not, because we have a side and an angle. That would make a bad word if you put those in order. That one is not one of our triangle congruence postulates. So the only ones that we can say that are congruent would be 1, 2, 3, and 5. We just don't have enough information about triangle 4 to say anything about it, so that one we leave out. Okay, let's look at one last example here. So we are given triangle ABC is congruent to triangle DEF. Let's go ahead and draw that. So we're going to have some information based on that statement right there. And make your triangles as big as you can. Here's triangle ABC and DEF. All right. And they tell us angle A is 70 degrees. Well, that means angle D will have to be equal to that. But let's see what else we have. They tell me angle B is y divided by 3 plus 20. And then they tell me angle C is 50 degrees. All right, I also know angle D is 3x plus 10. Angle E is 60. And angle F is z squared plus 14. So we're going to make equations for all three of those to find the values of x, y, and z. Let's start with x. So I'm going to use the fact that I know angle A matches with angle D. That's the first two letters in our congruent statements. So that's going to be 3x plus 10 is equal to 70. And then we can just use algebra here to solve. So 3x is going to equal 60. When we divide that by 3, we get x equals 20. All right, we're a third of the way there. Okay, now let's look at y. So here's angle YB. The second letter matches with E, the second letter here. So we can say y divided by 3 plus 20 equals 50. So first, let's get rid of that 20 by subtracting it from both sides. So these cancel. We get y divided by 3 equals 30. So the opposite of dividing by 3 would be multiplying both sides by 3. And these will cancel, and we get y is 90. All right, and our last example, we're going to find z. So 50 degrees matches with this z squared plus 14. C and F match. So if z squared plus 14 is equal to 50, you can solve that by subtracting the 14 from both sides. We get z squared is 36. Well, to get rid of a square, you have to square root both sides, and the square root of 36 is 6. All right, so we've got x, y, and z, and we are done with this problem. So that was a lot of information. If you guys have questions for me, feel free to comment down below, and I'll get those answered as soon as I can. Thanks for watching, and we'll see you guys next time.